Hello children, you are welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Uncle Agbaje. Today in mathematics, we will continue our work with numbers, but we will be looking at the least common multiple. What does that mean? We will find out in due course. But before we begin, as is our usual practice, we will look at the correction to the previous homework. In the last class, you were asked to express these numbers as products of prime numbers, that is, to write them out as multiplication of prime numbers. And you were taught what prime numbers are. Prime numbers have two factors, and so expressing these as product of prime, 2 goes in 84, 42 times, 2 goes in 42, 21 times. Now 2 can no longer go, 3 goes in 21, because obviously we've taught you how to check if a number can go, or 3 can go in a number. 2 plus 1 is 3, and 3 is a factor of 3. So 3 goes in 21 7 times, and 7 goes in 7 1 time. So now 84 is 2 times 2 times 3 times 7. And that is 2 in 2 places, 3 in 1 place, 7 in 1 place. Did you get that right? Good job you. Let's check out the next one. Here you are to express 120 as a product of primes. So 2 goes in 120 60 times, 2 goes in 60 30 times, 2 goes in 30 15 times. Now 2 can no longer go, but if you see 1 plus 5, that gives you 6. 3 is a factor then, because 3 is a factor of 6. 3 goes in 15 5, and 5 goes in 5 1. So you have 2 times 2 times 2 times 3 times 5, and that is 2 raised to power 3. 2 in 3 places, 3 in 1 place, 5 in 1 place. You got that right too? Of course, it was easy peasy for you, my friend. Let's check out the last one. Here we're dividing by 2s. 2 goes in 120 64, 2 in 64 32, 2 in 32 16, 2 in 16 8, 2 in 8 4, 2 in 4 2. Only 2s to divide this one. That is 2 times 2 times 2, and all the way to the end you have 2 in 7 places, my friend. Now did you get all correct? Then good job you. We're going to be using this knowledge in the course of today's lesson. Now to the sieve of Eratosthenes. Well, I did tell you that I would do mine, and when I did mine the way I asked you to do yours, I had all these numbers as the only prime numbers between 1 and 100. That is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 57, 61, 67, 71, 73, 79, 83, 89, and 97. Now if you miss out on some of these, go back again, draw the table of 1 to 100, use the sieve of Eratosthenes, and you will get prime numbers between 1 and 100. Now, for all the great work that you have done, I am going to celebrate you with a chair. Now moving on to today's learning objectives. By the end of this lesson, we should be able to identify multiples of given numbers. We should also be able to find the common multiples of given numbers, and finally we should be able to find the least common multiple of given numbers. What do all these mean? Let's check it out. So we begin with that question. First, what is a multiple? A multiple is many times of a number. Precisely, your multiple is what you get in your multiplications table. Many times of a number, as you will say. Now, here are some multiples of 6. This is 6. 6 in 2 places, that is 12. In 3 places, that is 18. In 4 places, that is 24. In 5 places, 30, 36, 42, 48, 54, 60, and so on like that. If you bring out your table of multiples here, you see 6, 12, 18. If you check your table of multiples, you see all the multiples of 6. All the numbers that you can get under 6 are what you call multiples of 6. 6 in many places. You can arrange 6 in many places. You get the multiples of 6. Precisely, the multiples of 6 are the numbers that 6 is a factor of. Okay, 6 is a factor of all the multiples. So these are the multiples of 6 once again. You go on and on, but let's just stop at 64. Now, I think you get the idea of what we're trying to say. So multiples of 4 as well, that means 4 in many places. This is 4 in 1 place, 4 times 1, 4. 4 times 2, 8. 4 in 3 places, 12. 4 in 4 places, 16, 20, 24, 28, 32, 36, 40, and like that, 44, 48. So that is what we call multiples. Now I want you to look at this diagram properly, and this will serve as your first activity. There are some numbers that are multiples of 4. They are also multiples of 6. Can you identify them? Begin. I want you to identify the numbers that are multiples of 4 and that are multiples of 6. You have 10 seconds and I'll count. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Bum, bum, bum. All right, let's check it out. Of course, we have 12. 12 is a multiple of 6. It's also a multiple of 12. You can see pulsing. I'll circle it for you. We also have 24. 24 is a multiple of 6. 24 is a multiple of 4. And we also have 36. 36 is a multiple of 6. It's also a multiple of 4. There are more. Okay, but within these ones that I have given here, we have just 3 common multiples. Okay. So we have 12, we have 24, and we have 36. If you go on along the line, you'll find 48 here. And 48 will also be a common multiple. These 12, 24, and 36, of course, we call them common multiples. It's a multiple of 6, it's a multiple of 4, then that means a common multiple of 6 and 4. I hope that this is clear. Okay. Now I want you to look at your table of multiples, your multiplication table. You have to find the first 3 common multiples of 6 and 8. You have to find the first 3 common multiples of 6 and 8. Check your table of multiples. I'll display mine in case you do not have it. You have 1 minute. Begin. Alrighty then, have you found them? Let's check it out. Yeah, first 3 common multiples of 6 and 8. So I look under 6, I look under 8, and I see their multiples. So 24 is here and 24 is here. That means that 24 is a common multiple. 48 is here and 48 is under 8 as well. And that means that 48 is a common multiple. Then 72 is here and 72 is here. And that means that 72 is also a common multiple. And we have found the first 3. But that question says, which is the smallest? So if you look at it very well, you see that 24 is the smallest common multiple of 6 and 8. And this number 24, this smallest common multiple, is very, very important in a lot of mathematics work. So if we want to find the smallest common multiple, is it all the time that we have to go back to the table of multiples? What if we want to work with numbers that are not on the table of multiples at the back of your book? Does that mean we will not find the least common multiple or the smallest common multiple? Well, no. There are ways by which we can easily find the least common multiple, and that is the crux of our work today. So follow me as we go. The first question says that we should find the least common multiple, which is the smallest common multiple of 6 and 8. We have found it to be 24, but now we want to demonstrate another way of finding it. So what we'll do is that we employ that method of prime factorization that we learned in our last lesson. We'll write 6, the first number, as a product of primes. That is 2 goes in 6 3 times, 3 goes in 3 1 time. And that means 2 in one place and 3 in one place. Then we do the same for 8. 8, 2 goes in 8 4 times, 2 goes in 4 2 times, 2 goes in 2 1 time. And we get 2 in 3 places. Okay. We have learnt this before, we just apply it. So how do we identify the least common multiple? Well, we need to focus on this box, these numbers outside the equality sign, the right side. This is where we need to pick our numbers from. Now all we need to do is that we observe that here we have 2 on this line, a column, and here we have 3. So this one has 2 in one place, this one has 2 in 3 places. The one that has the most number of 2's, you select that. This one is just 3 in one place. This one has no 3. So the one that has the most number of 1's, you select that. And in this case, this one has 2 in 3 places. So we select this one instead of this one. This one has 3 in one place. So we select just that. Like this. So 2 in 3 places, 3 in one place. That comes down. Then we multiply them together. Don't forget that 2 in 3 places does not mean 2 times 3. That's a banana peel for you, and you don't want to make mistakes there. So 2 in 3 places does not mean, when you have 3 on top of 2, it doesn't mean 2 times 3. It means 2 multiplying by multiplying itself 3 times. That is 2 times 2 times 2, and that is 8. So you see 2 in 3 places is 8, 3 in 1 places is 3, and that is 8 times 3. Get that number that we got before, which is 24. Now I'll take that again. When you have 2 and you have a 3 on top of it, it's not 2 times 3. It is 2 multiplying by itself 3 times. Yeah, this one has 3 numbers to find the least common multiple of, and it's possible. You can be asked to find the least common multiple of 3, 4, 5 numbers, depending on what you're working with. And we do it likewise. 18, break it down into primes. 2 in 18 is 9, 3 in 9 is 3, 3 in 3 is 1. So I have 2 with the power of 1, 3 with the power of 2, because there are 2 3's. When I go on to 20 and do likewise, 2 in 20 is 10, 2 in 10 is 5, 5 in 5 is 1. That's 2 with the power of 2, and 5 with the power of? With the power of 1. So I write that. 2 with the power of 2, 5 with the power of 1. Now observe what I did here. I put 2 under 2, but I didn't put anything under 3 because I don't want to put 5 under 3, so that it will be easy for me to identify them later on. So I do 50 likewise. 2 in 50 is 25. Then 5 in 25 is 5, and 5 in 5 is 1. That's 2 with the power of 1 and 5 with the power of 2. And this is how I write it. 2 with the power of 1, 5 with the power of 2. Observe again that I did not put 5 under 3. I put the 5 under 5. That way I can see columns. This is for 2, this is for 3, and this is for 5. I want to advise that you do the same. And of course, you know what we're going to do now is that we're going to focus on this box and select the 2 with the highest power. And the 2 with the highest power has the power of what? Has the power of 2. Good job, you. What about 3? That also has the highest power of 2. What about 5? Are we selecting the one with the power of 1 or the power of 2? Of course, we're selecting the one with the power of 2. We're interested in the strongest one. Okay, so that's 2 in 2 places, 3 in 2 places, 5 in 2 places. And mind you, 3 in 2 places, 3 with the power of 2 is not 3 times 2, so it's not 6. It's 3 multiplying by itself 2 times. That's 3 times 3. And you get 9 for that. 5 with the power of 2 is not 5 multiplying 2, is 5 multiplying itself twice. That's 5 times 5, and that, my friend, is 25. So eventually we have 4, which is 2 with the power of 2, times 9, 3 with the power of 2, times 25. And when you multiply that, my friend, we get 900. Now, I believe that by now you've been able to, cross out all gray areas, and you're ready for some activity of your own, which is coming up right about now. You are to find the LCM of 18 and 24. Easy peasy. So you have 1 minute, begin. Alrighty then, I believe that you are done, and let's see how it's done. Okay, so we write 18, split it up into prime numbers. 2 goes in 18 9 times, 3 goes in 9 3 times, 3 goes in 3 1 time. So we end up with 2 with the power of 1 and 3 with the power of 2. Then we do likewise for 24. 2 goes in 24, 12, 2 in 12 is 6, 2 in 6 is 3, 3 in 3 is 1. So we end up with 2 with the power of 3 and 3 with the power of 1. Now, did you get to this junction? Good job, you. So what do? We select the strongest of all the 2's, the strongest of all the 3's. Okay. So the 2 with the highest power is 2 in 3 places. 3 with the highest power is 3 in 2 places. So we just remember that 2 in 3 places, 2 with the power of 3 is not 2 times 3. It's actually 2 times 2 times 2, and that is 9. 3 with the power of 2 is 3 times 3. That is not 6. That is also, 2 with the power of 3 is 8. And 3 with the power of 2 is 3 times 3. And that is 9. So 8 times 9, yippee! Somebody said, I got it. Of course you got it right, because you are a smart kid. And I celebrate you. Now, it's time for your assignments, which of course, if you do, puts you in contention for a pack of Good Life Magic Juice. You have to find the least common multiples of these numbers. You have to find the least common multiple of 54 and 72. You have to find the least common multiple of 30 and 48. You have to find the least common multiple of 22, 66 and 132. You can have your table of prime numbers beside you as you work. With time, when you continue to work with it, you will become used to it. I trust that you have enjoyed yourself, and I trust that you have been able to learn 1 or 2 things from today's lesson. I have enjoyed myself. It's time to hand you over to Uncle Popo for the general studies lesson. Till I come your way in the next class, remain wonderful mathemagicians.